Hello everyone. We are doing the project number 2, which is Steganography, and our group name is XLT. My name is DaiZong.
My name is Wangbo.
My name is Xiong.
And we separate the project into 5 parts. I'm in charge of part 1 and part 2.
And I'm in charge of part 3 and part 4, which is embedding technique and recovering technique.
And I did part 5, which is making the GUI. And for the special features, we did them all together.
For the part 1 and part 2, I use 2 file, and for the flatten file, I create a function flatten, and the purpose is to convert grayscale image into black and white image. And for the input, I is hidden image which you want to embed, and I create a matrix with same size of the grayscale image. And for the uh, pixel which is less than 80, I assign to 1, which is black, and for the other is 0, which is white. For the part 2, the purpose is to convert 2D black and white image into RGB image, and for this part, I create 3 RGB layer and set up 3 RGB layer for every pixel in the image whose value is 1 into the 0, and then output the matrix.
So for part 3 and part 4, I did the embedding technique and recovering technique. Here I create 9 embedding and recovering technique. And for the first embedding method, I use the odd even number method in the for the right channel. So the embed one function have 2 input. The dog image is the image we need to change, and the hidden image is the image the user would choose to embed it in the dog image. And I firstly use the flatten function to make the hidden image into a black-white image, and then I assign the right layer of the dog image into matrix right, and for every matrix, for every pixel in the right layer, if it can be divided by 2, which means the mode of the number is equal to 0, I make the value less than 1. And for the value cannot be divided by 2, I made the value less than 0, and therefore change the right layer of the dog image. And finally to output the dog image with a changed right layer. For the corresponding recover one function, I just to use the same method, but here if the right channel of the embedded image cannot be divided by 0, then I assign 1 to the recovery matrix I made, which is a 2D matrix. This means I assign the corresponding recovery pixel with black color, and for others I assign with a white color. And finally, I use the expand function to expand the recovery image into a RGB image and output it. And for the method 2, and for the embed 2 and 3 file, it's just use all the even number method into the blue and green RGB channel. And for the embed 4 function, I make a change of the method I used, and here the aim of this method is to determine whether the numerical scalar in each pixel is a multiple of 3. And for the pixel who can be divided by 3, I make it no change. And for the pixel is not divided by 3, I make it less than the value of the remainder. So make the mode value equal to 0. And for others, uh, when the inflat function is a white color, I -1 with the right channel of the dog image, and if it's not a multiple of 3, I made the pixel number no change, and finally output the dog image with the red channel that has been changed. And the embed method 5 and 6 is also use the idea of whether the pixel number is a multiple of 3, but I changed the channel into green and blue channel. And for embed technique 9, here I changed the method again and to use a method to determine whether the last digit of the pixel is equal to 3. And here I use the blue channel, and for the embed 7 and 8 function I use red and green channel respectively. So it's totally is a 9 embed technique and 9 recovery technique. And here is recovery technique 4, which is to decide whether to recover the function to recover the output we have in embed 4, and the recovery 7, 8, and 9 is to recover the output we have from embed function 7, 8, 9.
So I used the app designer to make the GUI, and I first put axes and bottoms in the design view, and we can see that the hidden part and recover part are separate into two parts in this panel. And for the code, I had several properties written. Some of them are getting the hidden images uploaded, and some of them initialize the variables that we are gonna use throughout the program. They are changed in each function to work. And for each callback functions, we use if else and switch, and also we call the functions we wrote it in the files directly in the GUI functions.
So this is what our GUI looks like. And let me show you how to play with this GUI. Let's say we want to upload the normal image and the step 1, and then step 2, we can choose any hidden image you want to hide in this original image. Let's say we want to hide image 3, and this button here you can change the color of the image, invert the color, black to white and white to black. And there is a 4 option for you to play with the image. Let's say we want to flip it up and down, and let me choose the embed method 1. We can save it, name it 1. Here we upload the image we embedded and choose the recover method 1. Here shows exactly the same image. And what if you want to embed another image in it? You can click the button here. This button can clear all the input in the embedding method. And this button here, you click it, it can clear all the input for the recovery method. Let's say we still upload the normal image. We choose whatever and rotate it. Choose, let's say, method 7. Save it. Method 7. Okay, we use recovery method 7. It shows here. And actually we can embed more than one image into the dog image. Let me show you. So this image is what we embedded a hidden image 1 in it. Let's say we use method 2. Save it, name it 2. And then we upload 2 again. Choose another image. Let's image 9. Let's say choose method. Let's say choose a method 6. Save it. Image 3. And we upload the image. So method 6, it shows picture. And method 3, no, because we do not use the embedding method 3. Method 4, no. Method 2, yes, it shows the image. And method 1. And you still can even change the background color of this GUI. You can change the background color to pink, to yellow, and back to original. And that's it.